Okay, in this last video for a series of even cash flows, we're going to take a look at perpetuities. They are a special kind of annuity where the cash flows are occurring in equal amounts over equal intervals, but now there's not a limited time frame. It's going to last forever. The cash flows are going to last forever. We've got an annuity that just keeps going and going and going. So an example might be an annual payment of $10,000 each year forever. The perpetuity formula is a really simple formula. That's a nice thing about perpetuities. We're going to treat each cash flow as a lump sum, discount it back the appropriate number of periods, and we end up with the formula on this next page where we've got the present value of a perpetuity equal to the payment divided by the interest rate. So if we do that and look at an example here, we've got $100 every year and the interest rate is 5%. If we just divide $100 by 0.05, we end up with a present value of all those infinite cash flows discounted back at 5% equal to $2,000. Now the fact that we're getting $100 every year forever having a finite present value seems a little bit counterintuitive. What I want to do real quickly is take a brief trip over to Excel and show you a really long series of cash flows, $100 cash flows occurring every year. It won't be infinite, but it'll be long enough to show you that we're going to top out at $2,000 in terms of the present value of it. So let's go over to Excel real quick. And I'm going to set up a spreadsheet here. So here we'll have the year, and here we'll have the payment. And the payments are going to be $100 each year. I'm going to take both of those out a really long time. So let's go to 100 years. That's close enough to forever for our purposes here. And what I'm going to do right here is find out what the present value is for each of these cash flows individually. And the last thing we need here is an interest rate. And let's assume that the interest rate is 6%. So what I want to do is find the present value of each of these individual cash flows, and then we're going to add them all up. Okay, so that's what the definition of a present value of a series of cash flows is. In this case, the series goes on forever, but if we add up all these cash flows, that's the present value of the series. So I'm going to use the present value formula. So I've got the present value. The first input is the rate, which is 6%. The next one is the number of periods that I'm going to be discounting my cash flow. And I'm going to go over here and reference the cell. So the year number, I'm going to discount this cash flow 1 period. The payment I'm going to put in as a 0. The future value is the lump sum that I'm receiving at the end of that year. So that's where I'm going to reference the cell that has 100 right next to the 1. And so if I use that, it tells me that the present value of the $100, I'm going to go in here and add a little negative sign so my present value is still a positive number. The cash flow that I receive 1 year from now, in terms of today's value, it's worth $94.34. I'm going to copy that formula down. I already know it's not going to work because the reference to the interest rate is going to copy down too, and it's no longer attached to the interest rate. What I need to do is move that up. Oops. I need to edit that and change this reference to cell F1 and lock it. So by lock it, I mean make it an absolute reference. So if I hit F4, it'll stick on that cell, stick on F1, and now my formula is correct. The $100 that I receive 2 years from now is only worth $89 in today's money, in today's value, if the interest rate is 6%. And if I keep going down and copy this formula, you can see that each year the cash flow that I receive further and further out is worth less and less to me in today's dollars, right? So I'm going to go ahead and just copy that all the way down. And by the way, if you have a big series of numbers, you can click on the bottom right, actually double click on the bottom right corner, and it'll copy that formula all the way down to the very last row, the very last cell. And you can see after 100 years, the $100 that I receive 100 years from now is only worth to me 29 cents in today's money, okay, if our interest rate is 6%. So we've got this series of declining cash flows, a series of series of declining present values. And right now I'm going to add all of those up. So I'm going to use the sum function and add up every one of these 100 cells. And the value right now is 1661. So after 100 years, I've got a value of only $1,661. The total payments have been $10,000, right? 100 hundreds is $10,000 that I've received, but in terms of today's money, it's only $1,661. By the way, the present value of the perpetuity with our formula would be equal to the payment divided by the interest rate, so 100 divided by 0.06. So the correct answer for the present value of that perpetuity is $1,666. So look here, in the first 100 years, I've already got basically 99% of the value of my perpetuity. You can see that each additional $100 received way out in the future is going to be worth less and less to me, and at this point they're only worth pennies in terms of present value. So the present value of the perpetuity, it seems a little bit counterintuitive, but it does approach a limit that's equal to the payment divided by the interest rate. So that's the formula. Let's see here, some more notes on perpetuities. We can't find the future value of an annuity, right? If we're trying to find how much we'll have at the end of the annuity never ends. We have this infinite series of cash flows, so there is no future value. We also can't solve for the number of payments, the number of periods, I should say. It's going to, again, last forever, so there's no number that we can solve for. But we can solve for the other three pieces. We can solve for the interest rate, I should say the periodic interest rate. We can solve for the payment amount, or we can solve for the present value of the annuity. And in the last part of the video here, let's take a look at some perpetuity questions. The first one here, what is the present value of a perpetuity that pays $20,000 at the end of every year if the appropriate interest rate is 7.875%? Now, I want to show you how to do that in Excel with our 5 variables that we use on all of our time value calculations. But if you wanted to, you could use the very simple formula, right? We could take the present value, the payment amount, since we're paying $20,000 at the end of every year, and we're dividing that by the interest rate, so 0.07875. That would be our present value, $253,000 and change, right? If you want to use the 5 inputs, what we could do here, we're going to solve for the present value. The future value is nothing. There's no extra cash flows happening at the end. The number of periods in Excel, and hopefully I just showed you a minute ago when we looked at this sheet of a stream of $100 cash flows, if we pick an arbitrarily long period of time, we're gonna hit our perpetuity. We're gonna hit the value of our perpetuity. So I'm gonna just pick 1,000 periods here. So we're gonna act like this infinite series of $20,000 cash flows is really only going to last 1,000 years, which is again close enough to forever for us. The interest rate is 0.07875. The payment amount is $20,000. I made that 200. So if we solve for the present value with all of our inputs, the rate, the number of periods, the payment amount, and the future value, we get the same answer that we get with the formula. So just by making this n a really large number, we're going to get to the same place. Second question here, what is the interest rate for a perpetuity that is priced at $50,000 and pays $27.50 every year? So I'm going to put in my inputs here, $50,000, and I'm going to put a negative because it's priced at that, we're going to have to pay $50,000 if we want to receive these future cash flows of $27.50 every year. Future value is 0. The number of periods, we're going to again make it arbitrarily long. The payments are $27.50 every year, and we're going to solve for the rate. The number of periods is the first input, the payment amount is the second, the present value is the third, then the future value. Let's add some decimal places, and we would get an interest rate of 5.5%. Alternatively, we could use the formula where the present value is equal to the payment divided by the interest rate. If we rearrange things and solve for the interest rate, it's going to be equal to the payment amount, so it's going to be equal to $27.50 divided by the price, the present value, and if I divided those two numbers, I indeed get 5.5%. So you can use the formula, and it's simple enough with perpetuities to use the formula, or you can use the 5 things in Excel and use the Excel formulas, the Excel functions. So that is perpetuities. That's a series of even cash flows, and we'll pick up with uneven cash flows in a future video.